Hello, and welcome to the Discover Before Sleep channel. Tonight I will tell you the story of the year the world began to fall and rise at the same time. One man. Alone in a manor in Lincolnshire. A plague raging across the cities. And yet, in that silence, he watched a single apple fall. It was just a fruit, or so it seemed. But what if I told you that in that quiet garden, the invisible hand that holds the stars in the sky, the moon in its orbit, and the tides of every ocean, was quietly revealing itself to one young mind? So take a deep breath. Settle in. And let us step into the silence of 1666, where a man would teach the world how to fall, and why. The sky over Woolsthorpe was not the sky of a scholar, but the sky of a prisoner. In the year 1666, the world beyond the stone walls of the manor house was dissolving into a fevered nightmare. The Great Plague had turned London into a city of silenced bells and red crosses, driving the living into the hills, and the dead into the pits. Isaac, barely 23, sat in the suffocating stillness of his upstairs chamber, the silence of the Lincolnshire countryside, pressing against his eardrums like a physical weight. He was a man of shadows, a silhouette against the flickering candlelight that danced upon stacks of vellum and ink-stained quills. To the neighbors, he was merely a quiet, perhaps slightly odd young man, returned from Cambridge. To himself, he was a mind adrift in an ocean of unanswered questions, anchored only by the terrifying isolation of the plague years. The room smelled of stale tallow, and the metallic tang of ink. Outside the leaded glass window, the orchards were skeletal, their branches reaching upward as if pleading with a god, who had seemingly turned his face away from a dying England. Isaac did not fear the pestilence in the way others did, with hysterical prayers, or bundles of herbs pressed to the nostrils, but he feared the waste of time. Time was a river, and he felt himself standing on its bank, watching the water rush by, without understanding the mechanics of its flow. He watched the dust motes dancing in a single, lonely shaft of afternoon light, that pierced the gloom of his study. They swirled in chaotic, infinitesimal orbits, governed by rules he could sense, but could not yet name. He reached out a long, thin finger, trying to track a single speck of dust, but it eluded him, a tiny ghost in a miniature universe. His isolation was not a vacuum, it was a pressurized chamber of thought. He spent hours staring at the horizon, where the gray earth met the bruised purple of the twilight sky. There was a rhythm to the silence, a pulse in the emptiness. He began to see the world not as a collection of objects, but as a series of interactions. The floorboards beneath his feet were not solid matter, but a tension of forces holding him aloft, against the pull of the dirt below. He felt the heavy, thrumming heart of the earth beneath the manor, a silent giant exerting an invisible influence. The plague had stripped away the distractions of the university, the bickering of dons, the hollow recitations of ancient, dusty texts, that no longer satisfied his hunger. Here, in the quiet of his mother's house, he was forced to confront the universe on its own terms, without the filter of Aristotle, or the comfort of established dogma. The candles burned low, their wax pooling like cooling lava. Isaac's eyes were bloodshot, his fingers stained permanent black, by the reagents of his experiments. He was exploring the boundaries of the visible. He had begun to wonder if the light itself was a traveler, a messenger from a distant source, that carried within it the secrets of color and form. He ground glass in the darkness, the grit of the sand echoing the grinding of his own thoughts. He was alone, but he was populated by ghosts, the ghosts of Euclid and Descartes, whose ideas he turned over and over in his mind, like smooth stones found in a creek. But even they felt incomplete. They spoke of a world of clockwork, yet they could not explain the spring that moved the gears. The wind rattled the casement, a cold, biting draft, that made the flame of his candle shudder. Isaac did not pull his cloak tighter. He welcomed the cold, it was a reminder of the physical reality that he was trying to decode. He felt the weight of his own body in the chair, the way his muscles tensed to maintain his posture. Why did he not simply float away into the rafters? Why did the ink stay in the well, instead of drifting upward like smoke? These were the questions that filled the silence of 1666, the Annus Mirabilis, the year of wonders that was born from the womb of a great tragedy. He was a young man standing at the edge of a precipice, looking out into a darkness that he intended to illuminate, not with fire, but with the cold, hard light of reason. The days bled into weeks, and the weeks into months. The isolation became his sanctuary. He tracked the motion of the sun across his floor, marking the angles of the shadows with meticulous precision. He was building a map of the invisible, a geometry of the void. He sensed that there was a hidden language, a mathematical cipher, that underpinned every movement of the wind, every falling leaf, and every beat of the human heart. The world was screaming its secrets in a language of silence, and Isaac Newton was the only one listening. He felt the immense, terrifying scale of the universe pressing in on him, a vastness that made the plague seem like a small, flickering candle in a hurricane. He was alone in the dark, but in that darkness, the first sparks of a new world were beginning to catch fire. The stillness of the manor house often acted as a mirror, reflecting Isaac's mind back to the earliest flickers of his consciousness. As the plague winter deepened, he found his thoughts drifting away from the complex flux ions on his parchment, and toward the solitary boy he had once been. He remembered the feel of the cold, damp soil of the Lincolnshire fields, against his small palms, a sensation that had defined his childhood. He had been a posthumous child, born into a world that seemed to have no immediate place for him, a fragile scrap of humanity, who had arrived before his time. His mother's departure to a new marriage had left him in the care of grandparents, a transition that had carved a canyon of silence in his soul. In that silence, he had learned to speak to the wind and the water, finding a strange, rhythmic comfort in the patterns of the natural world that the adults around him seemed to ignore. He recalled with a haunting clarity the way he used to sit by the stream that cut through the edge of the property. While other children might have splashed or hunted for frogs, Isaac had been mesmerized by the eddies. He would drop a single willow leaf into the current, and watch, breathless, as it danced in the grip of the water. It was not the leaf that interested him, but the way the water curled around a stone, creating a miniature galaxy of foam and force. He saw the spiral, the way the energy dissipated and reformed, and he felt a desperate, wordless need to know why the water chose that specific path. He had begun to realize, even then, that nature did not act by whim. There was a hidden architecture to the world, a blueprint written in a script he could not yet read, but which he could feel pulsing beneath the surface of everything. His loneliness had been his laboratory. Denied the easy camaraderie of peers, he had turned his hands toward the creation of things. He remembered the small wooden clocks he had carved, the tiny mechanisms that tried to capture the invisible march of the hours. He had built a sundial, not merely to tell the time, but to track the sun's silent, majestic arc across the heavens. He would lie on his back in the tall grass for hours, his eyes fixed on the clouds, tracing their slow migration. He noticed how the wind pushed them, how they changed shape as if responding to a call from over the horizon. He was fascinated by the way light filtered through the canopy of the woods, breaking into shards of gold that shifted as the earth turned. Even as a child, he felt the gravity of the unknown pulling at him, a weight that was both a burden and a beckoning. There was a particular memory of a storm that had stayed with him throughout his years at Cambridge, and into his current exile. The sky had turned the color of an old bruise, and the wind had begun to howl with a predatory hunger. While the servants had scurried to batten the hatches, and huddle by the hearth, young Isaac had run out into the gale. He had jumped with the wind, and then against it, using his own small body as a measuring instrument. He felt the invisible hand of the air pushing him back, a force as real as a physical wall. He had measured the distance of his leaps, calculating the strength of the storm by the resistance it offered. In that moment, drenched to the bone and buffeted by the elements, he hadn't felt fear. He had felt a wild, electric connection to the mechanics of the earth. He was beginning to understand that the world was a great machine of infinite complexity, and that he was a part of its gears. He remembered the books he had kept as a boy, notebooks filled with the recipes for inks, the dimensions of bird wings, and the precise measurements of the shadows cast by the manor's chimneys. He had been a collector of data before he knew what data was. He would sit in the attic, surrounded by the dust of generations, and draw diagrams of windmills he had seen in the distance. He didn't just want to see the sails turn, he wanted to understand the transfer of motion from the invisible air to the heavy grindstone. He saw the world as a series of translations, one kind of power becoming another, a constant conversation between objects that never spoke a word. This childhood obsession with the how of things had isolated him further, marking him as a dreamer, or perhaps something more dangerous in the eyes of the superstitious. But to Isaac, the patterns were a form of prayer. He saw the Fibonacci spirals in the heart of a sunflower, and the hexagonal precision of a honeycomb, not as accidents, but as evidence of a supreme geometer. He felt that if he could only find the right key, the entire universe would open to him, like a well-oiled locket. This sense of a hidden order was what kept him from the abyss of his own melancholy. When the sting of his mother's absence, or the coldness of his grandfather's house, became too much to bear, he would retreat into the mathematics of the trees. He would count the veins in a leaf, noting how they branched with a consistency that suggested a law. He was a child seeking a father, and he had found one in the immutable laws of the cosmos. As he sat now in the candlelit room of his adulthood, the memories of that lonely boy merged with the analytical mind of the scholar. The curiosity had not changed, it had only sharpened into a needle-fine focus. He realized that the questions he had asked the stream and the storm were the same questions he was asking the stars. The boy had sensed the patterns, the man would prove them. The isolation of the plague was merely a return to the isolation of his youth, a necessary shedding of the world's noise, so that he could hear the low, steady hum of the universe's machinery. He reached out and touched the edge of his desk, feeling the solid resistance of the wood. It was the same resistance he had felt in the wind all those years ago. The boy was still there, jumping into the storm, waiting for the man to explain why he always came back down to earth. The transition from the memories of childhood to the cold reality of his research was not a leap, but a deepening of the same singular obsession. In the quietude of Woolsthorpe, Isaac began to look at motion, not as a byproduct of life, but as the very language of existence. He became a ghost haunting his own home, moving through the rooms with a focused intensity that made the walls seem to vibrate. He was no longer content with observing that things moved, he was consumed by the how and the why. To Isaac, a stone thrown across a field was not merely a stone, it was a mathematical entity tracing a curve through a resistant medium, a silent dialogue between the strength of his arm and the invisible grip of the world. He began to see the air itself, not as an empty void, but as a fluid, a thick sea that every object had to navigate. He spent days in the darkened parlor, experimenting with the behavior of colliding bodies. He procured a set of ivory spheres, placing them on a level table, and watching with a predator's patience, as they struck one another. The sharp clack of the impact would echo through the house, a solitary sound in the plague-stunned silence. He noticed how the speed of one was surrendered to the other, a perfect, almost sacred exchange of energy. It was as if motion were a substance that could be poured from one vessel into another, never truly lost, only redirected. He filled pages with diagrams of these collisions, seeking the hidden arithmetic that governed the rebound. He began to suspect that there was a conservation at work, a cosmic ledger, where every push and pull was meticulously recorded and balanced. This obsession led him to the study of the pendulum, the rhythmic heartbeat of the physical world. He hung weights from the ceiling beams of his chamber, sets of lead and wood suspended by silk threads. He would set them in motion, and watch for hours, his eyes tracking the silver arc of their swing. He noticed that regardless of the weight of the object, the time it took to complete a cycle remained hauntingly consistent. There was a tether between the object and the earth, a tension that dictated the pulse of the swing. He began to realize that motion was not an inherent property of an object, but a state of being. An object at rest wanted to stay at rest, an object in motion wanted to surge forward forever into the dark, stayed only by the interference of the world around it. This was a radical departure from the ancient teachings that suggested things move because they had an internal desire to reach their natural place. Isaac saw no desire, only law. His mind became a laboratory of the extreme. He imagined a world without friction, a perfect vacuum, where a sphere, once pushed, would roll across an infinite plane for eternity, never slowing, never wavering. He was peeling back the layers of the messy, tactile world, to find the skeletal structure beneath. He sat in the garden as the autumn leaves began to spiral down, and he did not see the beauty of the decay, he saw the acceleration. He noticed how the leaf did not fall at a constant speed, but seemed to gain a frantic momentum as it neared the soil. It was as if the earth were calling to it, its voice growing louder the closer the leaf came to home. He began to formulate the idea of inertia, the stubbornness of matter, the silent resistance that every atom offered, to a change in its state. This work required a new kind of mathematics, for the old geometry of static shapes could not capture the fluid nature of change. He needed to measure the instant, to slice time into segments so thin they were almost non-existent. In the flickering candlelight, he began to develop his method of flux ions. He was learning to calculate the rate of change at a single, frozen moment in time, the velocity of a falling stone at the precise midpoint of its journey, the curve of a planet's path as it veered through the void. He was inventing a way to track the ghost of a moving point, capturing the very essence of flight on the tip of his quill. The symbols he scratched onto the paper were like a net cast into a rushing river, trying to catch the water itself. His obsession became a physical weight. He would often forget to eat, the trays of bread and cheese left by his mother outside his door, going cold and untouched. He would wake in the middle of the night, his mind churning with the relationship between force and mass. He realized that the more stuff an object contained, the harder it was to move, and yet, once moving, the harder it was to stop. It was a beautiful, terrifying symmetry. He began to see the entire universe as a series of vectors, invisible arrows of force pushing and pulling, in a grand, silent struggle. Every footstep he took, every breath of wind that rattled the glass, every drop of rain that hit the sill, was a manifestation of these invisible laws. He was standing on the threshold of a great revelation, feeling the pressure of a truth that was almost too large for a single mind to hold. He felt as though he were walking through a thick fog, catching glimpses of a majestic cathedral just beyond the mist. He could see the outlines of the arches, the strength of the pillars, but the core of the structure remained hidden. He knew that there was a single, unifying principle, that connected the clack of the ivory spheres, to the falling leaf, and the orbiting moon. He was obsessed with the invisible strings, that moved the puppets of the material world. He was looking for the source of the pull, the origin of the push, the fundamental engine of the cosmos. And as the year grew old, and the plague began to wane in the distant cities, the mystery of the falling object was about to yield its most profound secret. The autumn of 1666 arrived, with a crisp, biting clarity that seemed to sharpen the very edges of the world. The garden at Woolsthorpe was a place of heavy, weighted silence, the apple trees sagging under the burden of their ripening fruit. Isaac sat beneath the boughs of a gnarled tree, his back pressed against the rough, lichen-covered bark. He was seeking a moment of respite from the stifling heat of his upstairs study, yet his mind remained a tempest of equations. The air was still, save for the occasional drone of a late-season bee, and the smell of fermenting fruit hung thick in the golden afternoon light. It was a scene of utter domestic peace, yet it was here that the architecture of the medieval world would finally crumble to make way for the modern. A soft, rhythmic thud broke the silence. A single apple, heavy and crimson, had detached itself from a high branch and tumbled to the grass. It was a common occurrence, an event repeated 1 billion times across the span of human history, yet to Isaac, it was a sudden, violent intrusion of reality into his theorizing. He watched the fruit settle in the clover, and a question, deceptively simple but devastating in its depth, crystallized in his mind: why does the apple always descend perpendicularly to the ground? He stared at the fallen fruit, as if it were a strange, celestial visitor. He looked up at the branch from which it had fallen, then back down to the earth. Why did it not go sideways? Why did it not fly upward toward the clouds? It was as if the earth itself were a giant magnet, possessing a will to draw all things toward its center. But he knew nature did not possess a will. It possessed laws. He began to envision an invisible line of force, a tether stretching from the very core of the planet to the stem of that apple. This force was not a mere local phenomenon, it was a constant, unrelenting pull that governed the fall of every leaf and the trajectory of every bird. He leaned forward, his fingers tracing the contours of a fallen leaf. If there was a drawing power in matter, it must be proportional to its quantity. The earth was vast, a colossus of rock and soil, and therefore its pull was immense. But did this pull end at the treetops? Did it dissipate like the scent of flowers, as one climbed higher into the atmosphere? He looked up through the thinning canopy, past the branches, into the pale blue vault of the sky. The moon was visible, a ghostly, translucent crescent, hanging in the afternoon light. It sat there, seemingly weightless, drifting through the ether. A radical, terrifying thought began to take root in his mind. What if the force that pulled the apple to the ground was the very same force that kept the moon in its orbit? The audacity of the idea made his pulse quicken. For centuries, the heavens had been treated as a separate realm, a place of divine, perfect circles, and ethereal substances, governed by laws entirely different from the crude, heavy physics of the earth. To suggest that the moon was, in essence, a falling object, was a form of scientific heresy. Isaac began to visualize the moon, not as a soaring deity, but as a projectile. He imagined a cannonball, fired from a great mountain peak. If fired with enough speed, it would curve downward, following the arc of the earth. If fired even faster, the curve of its fall would eventually match the curve of the earth's horizon. It would fall forever, never hitting the ground, perpetually trapped in a state of falling around the world. He grabbed a piece of charcoal from his pocket and began to scrawl on a smooth, flat stone at his feet. He was calculating the curvature of the fall. He realized that the moon was not staying up because it was light or divine, but because it was moving so fast that it was constantly missing the earth. Gravity was the invisible leash, the tension that prevented the moon from flying off into the void of deep space. The apple and the moon were brothers, subjects of the same universal monarch. The scale was different, the distances were vast, but the law was singular and absolute. The implications began to cascade through his mind, like a mountain stream. If the earth pulled the moon, did the moon also pull the earth? Did the sun pull the planets? Was the entire universe held together by a web of mutual attraction, a grand, invisible tapestry of pulling forces? He felt a sense of vertigo, as if the ground beneath him had suddenly become transparent, revealing the terrifying depths of space. He was no longer just a scholar in a garden in Lincolnshire, he was an inhabitant of a vast, interconnected machine. The silence of the garden was no longer empty, it was filled with the silent, humming tension of gravity, a force that reached out across the millions of miles to cradle the stars. He sat there until the sun began to dip below the horizon, casting long, skeletal shadows across the orchard. The apple remained in the grass, a small, red testament to a newly discovered truth. Isaac felt a profound sense of humility. He had caught a glimpse of the hand of the Creator, not in a burning bush or a divine revelation, but in the simple, humble fall of a piece of fruit. The world looked the same as it had an hour ago, but for Isaac, everything had changed. The wall between the heavens and the earth had been torn down. He stood up, his legs stiff from the cold, and looked up at the first few stars blinking into existence. He knew now that they were not just lights in the sky, but massive bodies, bound by the same geometry, that governed the pebbles at his feet. The mystery of the why had been replaced by the majesty of the how. The realization did not arrive as a thunderclap, but as a slow, agonizingly precise alignment of the spheres within his own mind. Back in his study, the candlelight flickered against the cold stone walls, casting a long, distorted shadow of Isaac as he bent over his desk. The apple had provided the spark, but the moon required the fire of mathematics to prove its kinship with the earth. He began to scratch out the proportions, his quill moving with a frantic grace. He knew the distance to the moon, at least in a general sense, from the observations of those who had come before him. He knew the rate at which the apple accelerated toward the clover. Now, he had to bridge the gap between the terrestrial and the celestial, a distance of some 240,000 miles. He began by calculating the force of gravity at the Earth's surface. He visualized the Earth not as a flat plane, but as a massive sphere, its power radiating from a single, dense center. The apple fell because it was being drawn toward that center. But the moon was far away, drifting in the silent periphery. If the force of gravity was like the light of a candle, it must grow weaker the further one moved from the source. He intuited a law of inverse squares, that if you doubled the distance, the pull would not merely halve, but would diminish to a fourth of its strength. It was a beautiful, geometric thinning of influence. To prove this, he had to compare the fall of the moon to the fall of the apple. The moon, he reasoned, was constantly falling toward the earth, but its forward momentum, its lateral velocity, kept it in a perpetual curve. He calculated how much the moon deflected from a straight line, every second as it orbited the earth. It was a minute measurement, a tiny fraction of an inch, almost imperceptible. Then, he looked at the apple. In the first second of its descent, the apple fell 16 feet. He compared the two. If his inverse square theory was correct, the Earth's gravity at the distance of the moon should be exactly enough to account for that tiny deflection in the moon's path. He sat in the oppressive silence of the midnight hour, his heart hammering against his ribs like a trapped bird. The numbers began to click into place. He adjusted for the size of the Earth, using the most recent measurements of a degree of latitude. He divided, multiplied, and subtracted, his mind a whirlwind of ratios. When the final calculation was complete, the results were not perfect. His data on the Earth's radius was slightly flawed, but they were close enough to be staggering. The force required to hold the moon in its orbit was almost exactly the same force that pulled the apple from its branch, weakened only by the vastness of the intervening space. The implications felt like a physical weight on his shoulders. The moon was no longer a mysterious, ethereal lantern, it was a heavy, rocky world, bound to the earth by an invisible chain of mathematical necessity. He looked out his window, at the silver orb hanging over the Lincolnshire fens, and felt a strange sense of kinship with it. They were both subjects of the same law. The same hand that pulled the tides, and governed the fall of a pebble, was the hand that swung the moon, in its great, silent circle. He realized that the earth was not the center of the universe, but it was the center of a local dominion, an anchor in a sea of motion. This was the bridge that no man had ever crossed. For 2,000 years, the human mind had been bifurcated, believing in one set of rules, for the dirt beneath their fingernails, and another, for the stars above their heads. Isaac had just unified them. He felt a profound sense of isolation, deeper even than the isolation of the plague. He was the only person on the planet who knew that the universe was a singular, coherent whole. He saw the celestial mechanics as a grand, interlocking puzzle, where every piece, from the smallest grain of sand to the largest planet, was connected by an invisible thread of attraction. He didn't celebrate. He didn't run into the streets to shout his discovery. Instead, he felt a deepening of his natural melancholy, a sense of the immense responsibility that came with such a vision. He began to see the entire solar system as a complex dance. If the Earth pulled the moon, then the sun must pull the Earth. And if the sun pulled the Earth, it must also pull Jupiter, and Saturn, and the wandering comets that terrified the populace with their fiery tails. He saw a universe held in a delicate, vibrating balance, a clockwork of such staggering precision that it could only be described in the language of numbers. The candles had burned down to stubs, and the first gray light of dawn was beginning to bleed into the room. Isaac laid down his quill, his fingers cramped and blackened with ink. He had traced the invisible leash of the moon back to the soil of his mother's garden. He had proven that the heavens were not a place of magic, but a place of mechanics. The mystery of the cosmos had not been diminished by this knowledge, rather, it had been elevated. The universe was not a collection of miracles, but a single, grand, ongoing miracle of order. He closed his eyes, and in the darkness behind his lids, he could see the planets spinning in their tracks, held fast by the silent, unrelenting grip of a force he had finally learned to name. The light of the rising sun did not bring relief, but a renewed, almost violent clarity. Isaac knew that the connection between the apple and the moon was only the foundation of a much larger cathedral. If the universe was a machine, he needed to define the very nature of the cogs and the tension of the springs. He returned to his desk with a renewed ferocity, the method of flux ions now a razor-sharp tool in his hand. He was no longer just observing, he was legislating. He began to draft the three pillars upon which all physical reality would eventually rest, the laws of motion. He started with the stubbornness of matter. He wrote of a world where objects were inherently lazy, possessed of a quality he called inertia. A quill resting on a table would remain there until the end of time, unless a hand, a force, disturbed it. But more radically, he realized that a body in motion would never stop, never veer, and never tire, if left to the vacuum of space. It was only the invisible interference of the world, the friction of the air, the rub of the floor, the tug of gravity, that brought things to a halt. This was his first law, the preservation of state. It painted a picture of a universe that was fundamentally persistent, a reality that required a cause for every change. Then came the measurement of the struggle. He looked at the relationship between the shove and the shift. He understood that the change in motion was always proportional to the force applied, and happened in the direction of that push. He saw it as a precise ratio: the heavier the object, the more force required to stir it from its lethargy. This second law provided the scales for the universe, allowing him to weigh the invisible. He could now calculate the exact amount of pull the sun exerted on the earth, simply by looking at the earth's mass and the curve of its path. The cosmos was becoming a ledger of forces, a grand equation, where every action had a predictable, mathematical consequence. But it was the third law that revealed the profound symmetry of the Creator's design. As he watched the recoil of a small toy cannon he had fashioned, he realized that force never existed in isolation. It was always a conversation. If he pressed his finger against a stone, the stone pressed back against his finger, with an equal and opposite intensity. There were no victims in his universe, only partners in a cosmic tug-of-war. To pull was to be pulled, to strike was to be struck. This symmetry meant that the Earth did not just pull on the moon pulled back on the Earth, dragging the very oceans across the globe, in the rhythm of the tides. The universe was a web of mutual accountability, where not a single atom could move, without whispering a reaction, to the rest of existence. With these three laws, Isaac moved to codify the ghost that had haunted his garden, universal gravitation. He sat back, his eyes tracing the lines of his own handwriting. It was not enough to say that gravity existed, he had to prove it was a universal constant. He wrote the formula that would define the heavens for centuries. He declared that every particle of matter in the universe attracted every other particle, with a force that depended only on their masses, and the square of the distance between them. It was a law of terrifying simplicity. It applied to the dust floating in his room, the ships on the Atlantic, the rings of Saturn, and the most distant, flickering stars. He was no longer just a mathematician, he was a mapmaker of the invisible. He saw the law of universal gravitation as the glue of the cosmos. Without it, the planets would fly off like sparks from a grindstone, lost to the infinite cold. With it, the universe was bound into a singular, rotating masterpiece. He felt the weight of this synthesis. He had taken the chaotic, frightening, and unpredictable world of the ancients, and replaced it with a world of perfect, predictable order. He could now predict the return of a comet, or the height of a tide, 100 years into the future. The room was silent, but for Isaac, it was filled with the music of the spheres, not the literal music of the Greeks, but a mathematical harmony. He had discovered the grammar of God. He looked at the stacks of parchment, the ink-stained results of years of isolation, and felt a strange sense of completion. He had transformed the miracles of the natural world into the mechanics of the natural world. But as he looked at the final, elegant equation for gravity, a cold thought crossed his mind. He knew what these laws did, and he knew how they measured the world, but he still did not know what gravity was. He had found the rulebook, but the hand that wrote it remained hidden in the light. The plague eventually receded, but the isolation of Isaac's mind only deepened as he returned to the cloisters of Cambridge. He carried with him a bundle of papers that contained the secrets of the heavens, yet for years he kept them locked in the cedar chests of his private thoughts. When he finally began to share his revelations, first with a few trusted colleagues, and eventually, through the publication of the Philosophiae Naturalis Principia Mathematica, the world did not greet him with immediate or universal acclaim. Instead, he found himself standing at the center of a storm of skepticism and intellectual resistance. The scholars of Europe, steeped in the comforting, centuries-old traditions of Aristotelian thought and Cartesian vortices, looked upon his invisible forces with a mixture of confusion and profound suspicion. To the established scientific minds of the 17th century, Newton's gravity felt less like science and more like sorcery. They accused him of reintroducing occult qualities into the study of nature. How, they demanded, could a body exert an influence across the vast, freezing emptiness of a vacuum? How could the sun reach out across millions of miles to grip the earth without any physical medium, no fluid, no ether, no invisible gears to transmit the pull? To many, this was a step backward into the darkness of mysticism. They were comfortable with a universe that behaved like a literal machine, where objects pushed each other, like the parts of a clock. Isaac's gravity, acting at a distance, without touching, seemed like a ghost in the machinery, or return to the magical thinking they were trying to escape. Isaac felt the sting of this resistance in his very marrow. He was a man of thin skin and a volatile temperament, possessed of a terrifying intellectual pride that made every critique feel like a personal assault. He engaged in bitter, protracted wars of ink and parchment with his contemporaries. They debated the nature of light, the priority of discovery, and the validity of his flux ions. Robert Hooke, a man of brilliant but restless mind, claimed he had arrived at the inverse square law first, sparking a feud that would simmer for decades. Isaac, retreating into his rooms at Trinity College, felt besieged by the litigious nature of the scientific community. He began to loathe the public stage, preferring the company of his crucibles and his silent equations to the bickering of the Royal Society. The resistance was not merely scientific, it was philosophical. If the universe were truly governed by immutable, mathematical laws, where did that leave the hand of God? Some feared that Newton was building a world that could run itself, a cold, mechanical cosmos that had no need for a divine architect to intervene in its daily affairs. Isaac himself struggled with this. He was a deeply religious man, albeit in a private, unorthodox way, and he spent as much time studying the prophecies of Daniel and the dimensions of Solomon's temple as he did the orbits of the planets. He argued that gravity was not a replacement for God, but a manifestation of his constant, sustaining will. Yet, to his critics, the math was too perfect, too autonomous. It threatened to turn the Creator into a mere clockmaker who had wound the spring and walked away. He spent nights pacing the confines of his chamber, the wooden floorboards creaking under the weight of his frustration. He had seen the truth in the garden at Woolsthorpe. He had felt the pulse of the universe in the fall of the apple. To have those truths questioned by men who had not seen the vision, who had not spent the lonely years in the dark with the numbers, was a torment. He felt like a prophet, speaking a language that no one else could hear. He would often refuse to publish his work, hiding his greatest discoveries in drawers for decades, driven by a fear that the world was not worthy of the light he had found, or perhaps that the light would be extinguished by the breath of fools. Yet, despite the mockery and the cold reception in certain quarters, the truth of his work began to exert its own gravitational pull. The mathematics were too elegant to ignore, the predictions too accurate to dismiss. While the philosophers argued over the essence of gravity, the astronomers were using Newton's laws to chart the heavens with a precision never before imagined. They saw that the orbits of the planets were not perfect circles, but the very ellipses Newton's math demanded. The resistance began to crumble, not because Isaac had won the argument, but because the universe itself was proving him right. Every telescope pointed at the sky was a silent witness to his genius. He remained a man apart, distrusted, feared, and often disliked, but he was becoming the undisputed legislator of the natural world. The transition was slow and painful. Isaac became a figure of legend, even in his own lifetime, the lonely giant of Cambridge. He had endured the plague, the isolation, and the biting wind of Woolsthorpe, only to face the even colder wind of human doubt. But as he sat in his study, surrounded by the mounting evidence of his success, he realized that the truth did not require the permission of the crowd. The laws of motion did not pause for the skeptics. The moon continued to fall, the tides continued to turn, and the invisible web of gravity held the world together, indifferent to the opinions of men. He had survived the storm of doubt, and in doing so, he had anchored the human mind to the bedrock of reality. As the years deepened into the twilight of his life, the man who had once been a lonely boy in a plague-haunted manor became the architect of a new reality. The world was no longer a place of shadows and whims, it had been transformed into a clockwork universe. Isaac, now the master of the mint, and the president of the Royal Society, sat in his London study, surrounded by the heavy trappings of authority, yet his mind remained fixed on the gears of the cosmos. He saw the universe as a magnificent, celestial machine, a vast construction of absolute space and absolute time, where every movement was calculated, and every event was the inevitable result of a prior cause. The chaos of the Middle Ages had finally been laid to rest. In its place stood a majestic, transparent order. Isaac's laws had provided the ultimate blueprint. He looked upon the solar system, and saw not a mystery, but a problem in mechanics, that had been elegantly solved. The sun, a massive, golden weight, at the center of the arrangement, exerted its pull, with mathematical constancy, keeping the planets in their orbits, like the weighted pendulums, of a great-grandfather clock. He could visualize the entire system, the slow, grinding rotation of the outer giants, the swift scurrying of Mercury, and the rhythmic, predictable return of comets from the outer darkness. It was a universe of law where the same rules that governed the fall of a coin in a London street governed the collision of galaxies. This vision of the world brought a profound sense of security to the human mind. For the first time, humanity felt it could predict the future. If one knew the position, the mass, and the velocity of every object in the universe, one could, in theory, calculate every moment that had ever passed, and every moment yet to come. It was a deterministic masterpiece. Isaac had removed the veil of the miraculous and replaced it with the mechanical. He saw God, not as a constant tinkerer, but as the supreme engineer, the one who had designed the gears, set the tension of the springs, and then stepped back, to let the magnificent machine run its course. This was the Newtonian synthesis, the merging of physics and astronomy into a single, unified truth. He spent his later years refining this vision, ensuring that the foundations were unshakable. He spoke of absolute space, an infinite, unmoving container, in which all matter resided, and absolute time, a river that flowed at a constant, unwavering rate, regardless of the observer. To Isaac, these were the fixed stage and the steady heartbeat of the Creator. He believed that the universe was a solid, dependable thing, as reliable as the gold he weighed at the mint. He had brought a terrifying clarity to existence, stripping away the fog of superstition and replacing it with the cold, hard brilliance of the geometric proof. Yet, even within this perfect clockwork, Isaac sensed a lingering silence. The mechanics were flawless, but the why of the force itself remained a ghost. He had described the gravity that held the stars, but he had never claimed to explain its origin. Hypotheses non fingo, he would say, I frame no hypotheses. He was content to show how it worked, leaving the ultimate nature of the force to the realm of the divine. He sat by his fire, the heat of the coals, a reminder of the energy that permeated the world, and felt the weight of the immense system he had uncovered. It was a world of cold beauty, a universe that functioned with the silent, uncaring precision of a diamond-cut gear. The legacy of the clockwork universe began to seep into every corner of human thought. It influenced the poets, the philosophers, and the kings. If the heavens followed laws, then perhaps society, too, could be understood through reason. The Enlightenment was being born from the ink of his Principia. Isaac had not just discovered gravity, he had discovered the idea of the system. He had taught humanity that the world was understandable, that the mind of man was capable of grasping the thoughts of the Creator. As he watched the hands of the clock on his wall move with a steady, relentless click, he knew that he had anchored the human race to a reality that was both magnificent and terrifyingly predictable. The machine was in motion, and it would never stop. The centuries that followed, the closing of Isaac's eyes, did not erode his monuments, they became the soil in which a new civilization grew. The clockwork universe ceased to be a radical theory and became the very air that humanity breathed. As the world moved into the era of steel, steam, and eventually, the cold vacuum of the high frontier, Newton's laws were no longer just marks on parchment, they were the invisible blueprints for everything man built. The silent garden at Woolsthorpe had expanded to encompass the entire globe, and the questions Isaac whispered to the falling apple, were finally being answered by the roar of rockets, breaking the bonds of the earth. Modern technology became the ultimate witness to the young scholar's isolated genius. When the first steel bridges spanned the great rivers of the world, it was Newton's second law that ensured they would hold against the weight of the gale and the thundering of the locomotives. Every skyscraper that pierced the clouds was a vertical testament to the balance of forces he had codified in the dark of the plague years. The world had become a vast, noisy laboratory, proving him right. Engineers did not guess, they calculated, using the method of flux ions to slice through the mysteries of stress, strain, and velocity. The invisible vectors Isaac had envisioned now governed the flight of every aircraft and the rotation of every turbine. But the most poetic proof lay beyond the atmosphere, in the very realm Isaac had unified with the earth. In the mid-20th century, as humanity prepared to cast its first metal messengers into the void, they did so using the exact geometry he had scribbled by candlelight. To launch a satellite was to perform the cannonball experiment Isaac had dreamed of beneath the apple tree. Scientists calculated the precise speed required to miss the Earth forever, placing artificial moons into the same silent, falling embrace that held the natural one. When the Apollo missions set their sights on the lunar surface, they were navigating a path carved out by the law of universal gravitation. The astronauts were not merely travelers, they were Newtonian projectiles, their every move dictated by the inverse square law he had derived in his 23rd year. The images beamed back from the edge of the solar system, the swirling storms of Jupiter, the majestic rings of Saturn, the lonely blue marble of Earth, were the visual realization of the Principia. We saw the celestial mechanics, not as abstract math, but as a visceral, terrifyingly beautiful reality. We watched as probes used the gravity of distant planets to slingshot themselves deeper into the dark, a sophisticated dance of mass and momentum that Isaac had seen in his mind's eye centuries before the first engine ever hummed. We confirmed that the universe was indeed a singular, coherent whole, where the chemistry of a distant star followed the same rules as a hearth fire in Lincolnshire. Even as the 20th century brought new theories, the curved space of Einstein, and the strange, flickering world of the quantum, Newton's laws, remained the bedrock. They were the limit to which all higher truths eventually returned. For the vast majority of human experience, from the driving of a car to the landing of a rover on Mars, Newton's world remains the true world. We live in the house that Isaac built. Our modern world is a place of precision because he refused to accept a world of chaos. Every time a GPS satellite synchronizes its clock, every time a ship navigates by the stars, and every time a child watches a ball arc through the air, the ghost of the lonely scholar is there, smiling at the predictability of the result. The technology that now defines human existence, the high-speed processors, the orbital networks, the deep space telescopes, is the fruit of that single, obsessive mind. We have taken the grammar of God and turned it into the language of industry. The mystery that once lived in the shadows of Woolsthorpe has become the infrastructure of the 21st century. We no longer fear the heavens, we map them. We no longer wonder why things fall, we use the fall to propel ourselves to the stars. The isolation of 1666 has been replaced by a global, interconnected awareness, yet at its core, it still pulses with the same three laws. Isaac Newton's vision was so vast that it took 300 years of fire and iron for the rest of the world to finally catch up to it. The shadows in the old manor house, at Woolsthorpe, have a way of lengthening that feels less like the absence of light, and more like the presence of a deep, ancient memory. In the final quiet of his long journey, the man, who had decoded the stars, found himself returning, in spirit, to the simplicity of the garden. The world now sees Isaac Newton as a titan, a cold monument of pure intellect, but the truth of his life was found in the tension between the chaos he felt and the order he craved. He had spent his decades chasing the invisible, trying to catch the breath of the Creator in the net of a mathematical formula. And yet, at the end of it all, he remained a man, standing on a shore, looking out at a horizon that refused to reveal its final secret. Gravity, he realized, was more than just a force of attraction. It was the ultimate expression of a universe that desired to be whole. It was the silent, persistent pull that held the atoms of a tear together just as firmly as it held the galaxies in their spiraling dance. He had discovered that we do not live in a world of accidents, but in a world of consequences. Every action has its shadow, every push, its pushback, and every distance, its diminishing grip. There is a profound, almost poetic comfort in this order. It suggests that the universe is not a screaming void, but a structured sanctuary, where nothing is ever truly lost, only transformed, or redirected, by the laws of the machine. He often reflected that he felt like a small boy, playing on the seashore, diverting himself, and now and then, finding a smoother pebble, or a prettier shell, than ordinary, whilst the great ocean of truth lay all undiscovered before him. This was not the false modesty of a famous man, but the genuine vertigo of a mind that had looked into the infinite. He had found the laws of motion, but he had also found the limits of the human vessel. He had shown that the universe was a clock, but he knew that even the most perfect clock eventually needs the touch of the master's hand to maintain its rhythm. The why of gravity, the essence of the pull itself, remained a sacred mystery, a divine whisper that math could translate but never fully explain. The order he found was a gift of certainty in a world of plague and doubt. He taught us that the same gravity that brings the apple to the earth is the gravity that prevents the stars from drifting away into a lonely, eternal dark. It is the bond of the cosmos, a universal embrace that ensures no part of existence is ever truly isolated. We are all tethered to one another and to the heavens by these invisible threads. To understand gravity is to understand that we are part of a grand, unfolding story that began with a single spark and continues with the silent, rhythmic motion of the spheres. As the candle of his own life flickered toward its end, Isaac Newton did not fear the stillness. He had spent his life proving that stillness is merely a state of potential, a rest between forces. He had brought light to the darkness of the medieval mind, not by inventing new worlds, but by revealing the true nature of the one we already inhabit. The apple tree in the garden would eventually die, and the manor would crumble, but the laws he scribbled in his lonely youth remain as fresh and as absolute as the day they were first conceived. They are the eternal grammar of reality, the silent music that plays on even when there is no one left to hear it. Gravity is the weight of the universe's love for itself, the constant desire of all things to be near to the center. And as Isaac drifted into the final, absolute time of his own existence, he did so with the peace of a man who had seen the gears of the world and found them beautiful. He left behind a world that was no longer afraid of the dark, for he had shown us that even in the deepest shadows of space, there is a law, there is a reason, and there is a magnificent, unchanging order.